Hey guys, I'm gonna be sort of rationalizing that I thought in my head. Okay, so basically, if something is zero order, each half-life will cut the concentration in half. So when we observe here for zero order, the diminishing concentration doesn't affect the rate. So we can identify this by seeing that from 0 to 30 seconds, our concentration splits in half. And then from 30 to 60 seconds, our concentration splits in half again. That's a zero order. Now we have first order. First order, we have our timestamps. So from 0 to 30 seconds, the concentration cuts in half. But then from 30 to 45 seconds, the concentration cuts in half again. And what we can say about this is that each time you cut the concentration in half, half of that time cuts the concentration in half again. So if you're taking 30 seconds for the first half-life, your second half-life will be 15 seconds. And then your third half-life will be half of 15 seconds. Hence why it goes from 45 to 52.5, because you're adding 7.5 seconds. That is a first order. It's time to cut in half is half of the total cut, if that makes sense. The time to half is half of the total half-life. I know it's kind of written weird, but now we have a second order, which I do not understand why I was doing these in class. So we observe in the time here that it takes 30 seconds to cut this in half. So the amount of time needed to cut this in half will double. So it took 30 seconds to cut this in half. Now, wait, I need to rationalize this in my head. Shouldn't that be a 60? Right here. It's not a 60? I don't understand why it's not a 60 here. Amount of time needed to cut in half, the half-life, is doubling each time. So it goes from 0 to 30, let's say. And then it should go 30 times 2, that's 60. 60 times 2 is 120. Shouldn't this be... I don't know. I will ask my teacher about this. Point being,